In this video, I'm going to go over solving some right triangles using angles of elevation and angles of depression. Now I have here on this very first part of the paper, giving you the definitions of angle of elevation and angle of depression. So you can see by my figure that I've drawn with the boat and the lighthouse that the angle of elevation is the angle between a horizontal line and a line of sight to an object above the horizontal line. So here is that horizontal line. So the same, very similar drawing to the right of that for the angle of depression, but I just have the person looking down at the boat, and the angle of depression is the angle between a horizontal line and a line of sight to an object below the horizontal line. So again, this is the horizontal line. I think the angle of depression is the one that gets students mixed up the most, but hopefully these figures, when you draw them, you'll remember that it has to be within or made with a horizontal line. If you're not making the angle using at least one horizontal line, then it's not going to be one of these angles. All right, let's try the first one. So the angle of elevation from point A, on the ground to the top of a cliff. All right, so let's say this is the top of the cliff up here. All right, is going to be 34 degrees. So this is 34 degrees right there. And then I'm looking at that point A is 1,000 feet from the base of the cliff. How high up is the cliff? So in this case, using my trigonometry understanding with SOHCAHTOA, I'm looking for the side that is opposite my angle of 34 degrees, and I'm given the adjacent side, that distance from the base of the cliff to the point. So I'm going to use tangent to solve this one. So tangent of 34 degrees equals, I don't know how high the cliff is, over 1,000 feet. Because my unknown is in the numerator, I'm just going to go ahead and multiply both sides by 1,000 to move that to the other side. So my answer, my exact answer, is the height of the cliff is equal to 1,000 times the tangent of 34 degrees. All right, now I'm going to find an approximate answer and round this to the nearest hundredth. So I'm going to say the height of the cliff is approximately, and I'll type in 1,000 times the tangent of 34 degrees. Go to degrees. All right, here we go. 1,000 times the tangent of 34 degrees, which is approximately 674.51 feet. 674.51 feet. All right, so that's how we do that first question. I'm going to do two more, number 2 and number 3, and I'll let you guys look at the key for 4 and 5. So the angle of depression from the top of an 80-foot building to point A on the ground is 42 degrees. So I'm going to draw my building. All right, so here's the building. All right, and it says from the top to a point on the ground. So I'll do that point again. Here's point A. All right, and that angle of depression. So I'm going to draw that horizontal line to make my angle of depression. All right, which tells me this angle is 42 degrees. Now it does say that the building is 80 feet high, or that's the top of where they're looking down. How far is the foot of the building from point A? So essentially, what is this distance here? All right, now you could, if you wanted to, since this is a horizontal line, you could subtract 42 from 90 to find this angle here. But most students are just going to use the fact that this angle down here, if you're looking up at the building from point A, that angle of elevation would be 42 degrees. So I'm going to go ahead and do that route of this. But again, it should be the same answer, even if your work looks a little different. So I'm going to do the tangent of 42 degrees equals the opposite, which is my 80 feet, over the adjacent side. I'm going to put this over 1 because my unknown is in the denominator, and then do cross products. So my unknown times the tangent of 42 degrees equals 80 times 1, which is just 80. To get the exact answer, I'm going to divide by the tangent of 42 degrees from both sides, and that will isolate my unknown. So my exact answer is 80 over the tangent of 42 degrees. To get an approximate value here, I'll use the calculator. So this is how far, so let's say, I'll say this right here is approximately. So 80 over the tangent of 42 degrees is going to be, to the nearest hundredth, 88.85 feet. 88.85 feet. That is my approximate distance from the foot of the building to point A. Okay, let's do number 3, and then I'll let you guys take a look at 4 and 5 on the key. So number 3 says, a tree, just 40 feet high, so here's my tree, very large tree, 40 feet high, casts a shadow that is 58 feet long. So I'll have my shadow 58 feet long. So that means I must have my sun somewhere up here, right, shining down. Okay, so I'll make that triangle. And it says, find the angle of elevation of the sun. So essentially, if I'm down here on the ground looking at the sun, can I find that angle there? And I'll just call that theta. All right, so using my trigonometry, I'm going to write tangent of theta equals 40 over 58 feet, right? Opposite over adjacent. Now, the exact answer for theta, because I got to go backwards, is tangent to the negative first power of 40 over 58. That's the exact answer. All right, but my approximate angle here, if I were to type that in, is tangent to the negative first power of 40 over 58 is going to be approximately 34.59 degrees. All right, so you got to see 3 different variations there with the angle of elevation and depression. Probably the most basic one at number 1, where you're given the angle of elevation, you're finding the opposite side, so kind of your most basic tangent. Then we had the second one where it was a little bit more difficult because of the angle of depression, and we're finding the unknown in the denominator, so I made a proportion. And then finally the last one was using our understanding of trig to find an angle of depression, angle of elevation. So we had to kind of go backwards, tell the computer or calculator, I know the ratio for tangent, can you tell me the angle that would give me that ratio? All right, so check out 4 and 5 on the key, and good luck.